Can you hear me?
Yep, we can hear
Yes.
you.
Okay.
Thank you.
So good afternoon, everyone. This is my paper, a self-aggregated hierarchical topic model for short text. Short text is a kind of very common and prevalent text on the internet. These are some examples about the tweets on Twitter. So we can see the length of this kind of text is very short. Regular size text may have contains more than 100 words, but in short text, we can say the average length of this text may be less than 10 words or less than 20 words. So we can see that this kind of text, this kind of short text everywhere on the internet, and there are a lot of useful knowledge in this text, and we want to discover knowledge from them. Hierarchical topic model is one of very useful knowledge discovery method, and this is an example of hierarchical topic model. It's a tree structure. The nodes of this model, we can say it is constructed by several words, and that means each node is a topic, and the topic is a concept, and there are lines between topics. The lines means the relation between topics. The relations between father topic and child topic is a taxonomy relation. So if we discover, if we construct this tree structure, then we can know the concept of a short text set, and we also can know the taxonomy relations between these concepts. But in order to generate this topic tree, we relied hierarchical topic models rely on two kind of thematic relations. One kind of relation is word co-occurrence relation. What is word co-occurrence? That means if a two word appears in one short text, that means the word co-occurred in a text. So the word co-occurrence information is about words that appears in one short text. And then the second information is general special word relations. What is general special word relations? We know if a word is very general, it appears in many texts, and a word is a special word, and then it appears in only a few texts. So what general special word relations can help us to generate the taxonomy relations between topics, but also in short text. The short text is very short. Word co-occurrence is sparse in short text, and the general special word relations also is sparse, or we can say sometimes general words didn't appear in many short texts, but the special words may appear in many short texts. So the general word relations is broken in short text. So because of this kind of thematic information sparsity, some works try to overcome it. THLD is one of word for tweets in Twitter. They incorporate word embedding information. So word embedding information is auxiliary information. All this word embedding information is generated from Google News. It is an auxiliary document corpus with irregular length documents. Of course, word embeddings can provide additional thematic information to help overcome this problem, but this method needs users to construct a regular-sized document corpus. if you can't find auxiliary document corpus, you can this method will not work. And so another kind of strategy is pooling method. Pooling method aggregating short text by the metadata. We know like tweets, they have hashtags, and we can find the writers of each tweet. So they use this auxiliary information to aggregate short text into long documents. The long document is a regular length document, so we don't. So the problem of word co-occurrence and general special word relations, they are not sparse. And this auxiliary information is not very common in different kinds of short texts. And also they are not easy to, they are unavailable in some short texts. So PTM, the self-aggregated short token model is proposed. This kind of model generates short text into long documents heuristically. And they also use long documents to add additional word co-occurrence, but they cannot add word general special relations. And they also cannot provide a hierarchical taxonomy topics with taxonomy relations. So our contribution. Our research proposed a self-aggregated hierarchical topic model, SHPAM. We also, inspired by the related works, we also heuristically generate short text into long documents. And the long documents, we think they can provide sufficient word co-occurrence information. And also because the long documents is constructed by short text, they also can provide additional general special word relations. Then we measured our model. We designed a metric of topic coherence. It is PMI score. And then we compared our model with several state-of-the-art methods on 4 real-world short text. The result is shown that our model is more coherent compared to the others. This is our model, the generation process of our model. There are 4 steps. The first 2 and 3 steps are the sampling priors and sampling the parameters of the distribution. And the 4th step is a basic general process. First, for every short document D, we first sample the latent document according to a multinomial distribution. Every short text share a same multinomial distribution. Then for each word W in WG in short document D, we first sampled the root, the super topic, that is the root topic in the tree. That is the first node and at the first layer. And if this tree is, if the root node is sampled, then we sample the word WG from a multinomial distribution. But if the root node is not sampled, it means the word should be sampled from child nodes of the root node. So we sampled a subtopic T. We sampled the child topic of this node topic. But so if we sampled, if the word is not sampled from the child topic of root, that means the word should be sampled from the leaf nodes. So if we so we sampled this word from the leaf nodes and according to the multinomial distribution, and this is the graphical model of our method. These parameters, these are parameters and the priors. So we build a distribution. Our distribution is about 4 variables. The first one is the latent long document. and the second one is topics about the tree and the structure, the relations between topics. And the second one is the words. The words are already known. So there are two kinds of latent variables that are unknown. The first is the latent long document, and the second is nodes in the tree. Then we can use the drift sampling method to infer these two kinds of latent variables. The inference method, there are two steps. The first step is sampling the latent variable long document according to the equation as follows. Then the second one is sampling topics of different layers. There are three layers in our model. The first one is the root nodes and the root, obviously the root topic. Second one is the child node of the root topic. And the second one is the leaf nodes. So we sample the root topic of first layer according to the equation, and then sample the child node of the root node, and then sample the leaf node at the third layer. After this sampling, then we can, for every short topics, every word in short topic, we sample following a path from root nodes to its child node and to the leaf node. The experiment, we compared our method with others on 4 real-world data sets. The first is news titles. The news titles are from RSS, and then we use the DBLP, the titles of computer science papers. Then we use some tweets from the Twitter, and also the Reddit news from the Reddit website. It's also the news titles. That is statistics of data sets. There are 3 kinds of statistics. First is the document size, how many documents. And the second is the dictionary size. And the third is the average length of each short text. So we can say news titles is a little bigger. They are average 18 words, and DBLT tweets and Reddit, the average size is less than 10 words. Methods we compared to HPAM, we employed this method as the base method. The model of this method suggests that each document has a distribution over the whole tree. And NCRP is a typical model of hierarchical topic model. This model suggests that each document is a distribution over a path of the tree. But this model should automatically generate the height of the tree and the number of topics of each layer. And HVPM is the state-of-the-art method of DHI structure model. So this model can be seen as hierarchical HDP. Every level of this model is HDP. The evaluation score, PMI score, we choose the latest dump of Wikipedia articles as auxiliary data. This article set contains 5 million documents and 14 million words of vocabulary. First, we build a sliding window, 10 topics, and then we use this sliding window to generate word co-occurrence information. And then we calculate the PMI score according to this equation. And then we'll get the PMI score of every 2 words in Wikipedia. So we choose top 10 topics or top 10 words of each topic. And then we calculate the average PMI score according to the Wikipedia words. And the average PMI score of all topics, the higher means the topics are more coherent. So this is our experiment result. We can say the NCRP is the worst one because this model need to infer, not only infer topics and the relations of topics, it also need to infer the height of the tree and also the number of topics of every layer. So this is the worst. And HPM and HVPM is a little better than HPM, especially on dataset twists and Reddit. And the green one is our method, SHPM. SHPM is the best one compared to others. That means our model is, the topics of our model is more coherent than others. Conclusion. We proposed a self-aggregated hierarchical topic model for short text. So the short text, they lack word co-occurrence and general special word relations. But when we generate short text into latent long documents, the long documents successfully brings a sufficient word co-occurrence, and they also bring additional general special word relations. So our model, the topics of our model, is much more coherent than others. In future works, I think we need to incorporate additional semantic information, such as document embeddings. Word embeddings, we need other auxiliary corpus. So I think this is not a good way. And document embeddings, maybe it's a better solution. That's all.